finding unknown angles. So in the last video we looked at finding unknown sides, and here we're going to look at finding unknown angles. But in order to do that, we just need to learn something really important. So if we have sine theta equals a number, how are we going to solve for theta if we don't know it? Well, we can do something called the inverse function. And what that does is it switches a and theta. So theta becomes the subject, and then we get the inverse sine of a. And you can get that on your calculator by pressing the shift button and then sine. And this works for cos and tan as well. So theta here would equal the inverse cos of a, and tan theta equaled a theta would equal the inverse tan of a. Let's look how we can use that information in solving a question. So we've got a right angle triangle with an unknown angle, this time theta, and we have two sides. And we can use trig to find this angle. We still have to go through our process and label the sides we're interested in. So the one opposite the right angle is the hypotenuse, and this is the angle we're referencing. So this one is the opposite. And the trig function that uses opposite and hypotenuse is sine. So we have sine of our angle always equals the opposite over the hypotenuse. Let's put in everything we know. We don't know the angle this time, so we leave it as theta. The opposite side is 6, and the hypotenuse is 10. And we use our special property up here to make theta the subject. So theta equals the inverse sine of everything on the right hand side, which is 6 over 10. So putting that in our calculator is going to give us 36 degrees, 52 minutes, and 11.63 seconds. Yours might come up as a decimal, but you can hit the degrees, minutes, seconds button on the calculator to give your answer in degrees, minutes, and seconds. Now, if we wanted to round it, let's say to the nearest, so the first number is degrees, the second number is minutes, and the third number is in seconds. There's 60 seconds in a minute, and there's 60 minutes in a degree. Very similar to time, where you can think of degrees as hours. So when this number is 30 or higher, we round this one up. And when this is 30 or higher, we round this one up, depending on how we want to round it. So if we're rounding to the nearest degree, this is 30 or higher, so the 36 degrees becomes 37 degrees to the nearest degree. Let's look at another example. So we don't know this angle, called theta. This side's 10 and this side's 4. So I'm going to label the sides that we're interested in. So this one is opposite the angle we're referencing. This one is next to the one we're referencing, so it's the adjacent. So the trig function that uses opposite and adjacent is tan, because tan of an angle equals the opposite over the adjacent. Let's put in everything we know. We don't know the angle, so it's theta. The opposite side is 4. The adjacent side is 10. We need to make theta the subject. So you can imagine taking the tan to this side, and it becomes inverse tan. We can put that in our calculator, and we get 21 degrees, 48 minutes, and 5.07 seconds. If we wanted to go to the nearest minute this time, well, this is not 30 or higher, so that 48 stays as 48 minutes. So we get 21 degrees and 48 minutes to the nearest minute this time. One more example. So we don't know this angle. This side's 16, and this one's 28. Label the sides we're interested in. Well, the one opposite the right angle, that's the hypotenuse. This one's next to the angle we're referencing, so it's the adjacent. Which trig function uses adjacent and hypotenuse? Well, that's cos. Cos of our angle equals adjacent over hypotenuse. Let's put in everything we know. We don't know our angle, so it stays as theta. The adjacent side is 16. Our hypotenuse is 28. We're going to move cos over there because we want to figure out what theta is, and it becomes the inverse cos of 16 over 28. Using our calculator, we get 55 degrees to the nearest degree.